the questions on quadratic equation that I just kept? Yeah. No answer. Did anybody attempt? Questions on quadratic are slightly on a tougher side. Okay, not like trigonometry.
Yes, so I attempted part.
Yeah, good. Trigonometry questions were easier. This was slightly on the tougher side. Okay, now I share the screen and I'll continue what we did yesterday. So we were doing a problem that for this quadratic equation, x square minus of just hold on, x square minus of m minus 3 x plus m. Find the values of m for which various conditions. Roots are real, distinct, roots are so various of such conditions. Okay, so a few more. So we completed both roots are lesser than 2. Okay, next. Today's date. Now, next is exactly one root lies in the interval 1, 2. Exactly one root lies in the interval 1, 2. So there are two roots and they are real and distinct, but exactly one root lies in this interval. Again, this is the equation. This is the discriminant. Discriminant greater than 0, which implies x belongs to minus infinity to 1 union 9 to infinity. So this is a common condition for all questions. Now, exactly one root lies in the interval 1, 2. How will we do this? Anybody has any idea? I'll draw the graph.
The equation at 1 will be positive, but at 2 it will be negative.
Very good. Yes, you're right. You're right. But it may be other way also, because it can be at 1 it can be positive and at 2 it can be negative, or at 1 it can be negative, at 2 it can be positive. See, this is, sorry, Okay, I plot 1 and 2. Now exactly one root lies here. Parabola is opening upwards. Okay, parabola can be like this, or it can be like this. So alpha, beta, alpha, beta. So you're right. So uh, f of 1 in this particular case, f of 1 is negative and f of 2 is positive. Okay, and here f of 1 is positive and f of 2 is negative. So another way of saying it is the product, both these conditions simultaneously, if you have to do, you will write the product of f of 1 and f of 2 is negative. That means they both are of opposite signs. Okay, so what is f of 1? Substitute 1 in this expression. 1 minus m minus 3 times 1 plus m. So what happens? M and m cancels. You get 1 plus 3 is 4. Next, f of 2 is x square minus m minus 3 times 2 plus m, which is 4 minus 2m plus 6 plus m, which is 10 minus m. So product of roots is negative. Sorry, not product of roots. Product of these two values is negative. So you get you get 4 into 10 minus m is negative, which implies 10 minus m. So 4 you can remove because it's a positive number. 10 minus m is negative, which implies you multiply with minus 1. So m minus 10 will be positive. Whenever you multiply with minus 1 an inequality, it reverses. So m greater than 10. And our basic condition is, sorry, here this should be m. M lies outside of 1 and 9. So m greater than 10. So combining this, m should be greater than 9 and m should be greater than 10. So we get m is greater than 10. M belongs to 10 to infinity. Got it? Now, what if same conditions, uh, everything same, if both roots lie in the interval 1 comma 2. Here exactly one root lies. Now both roots lie in 1 comma 2. Then what will you get? How will you get the equation?
So the product of both the functions of 1 and 2 will be positive.
Very good. Very good.
And sir, we need to take the other condition where we subtract both the conditions and it will be negative. Like we subtract the functions of, we add the functions of 1 and 2 and it will be negative.
Why?
So because it's like, even if they were positive, the product would have been positive. So.
No, look at the graph. Both roots lie between 1 and 2. And coefficient of
Positive and negative, no, sir.
pardon?
It can be positive or negative.
What
The
will be
function of
positive? No,
the
it
function
will
of
function at 1 will only be positive because that is coefficient of x square is 1, which is positive. So parabola will only open upwards.
okay, sir. Okay, sir.
So it will cut at 2 points which lie between 1 and 2. So f of 1 and f of 2 both will be positive. So first condition says d greater than 0 will give us m lies outside of 1 and 9. And now second condition is f of 1 into f of 2 is greater than 0. So you have 4 into 10 minus m is greater than 0, which implies, okay, m will be less than 10. So now you have to combine this. M is less than 10 and m lies between, minus infinity to 1 union 9 to infinity. So what will be the answer?
But then I guess
Minus
M can be something 9, like below more than 9, more than or equal to 9 and less than 10, or more equal to 1 or less than that. Because according to this, M can't be something between 1 and 9.
M can't be between 1 and 9, right?
So
So,
we will have to write it twice, I guess.
okay. So m has to lie, and one more, say individually f of 1 is 4, no problem. F of 1 is 4 and correct. F of, so that is, so f of 2. So m will belong to minus infinity to 1 union 9 to 10. Minus infinity to 1 union 9 to 10. All right. One more condition you have to check. One more condition you'll need to check is that this minus b by 2a should lie between 1 and 2. Okay, let us see whether that happens. All right, let us see whether this happens. 1, this is minus b is m minus 3 by 2 should lie between 1 and 2. So multiply throughout by 2. In previous case, you cannot say that because it can be anything. But in this case, this is a must. Now you add 3, 5m less than 7. Now this condition gives m cannot lie between 1 and 9. M can lie between 9 and 10 and less than 1. But this condition gives M should lie between 5 and 7. So intersection of 1 and 2 is null set. There is no possibility. Therefore, for there is no value of M for which both roots lie in 1, 2. All right, this one minus b by 2a axis, that should lie between 1 and 2. So that is what we did. All right. All right, most of the cases have completed. One case, both roots are greater than 2. Both roots are lesser than 2. So all cases are over. Okay, 1 or 2 exceptions may be there. So this is how we solve problems like this. All right. Now another thing that I have to teach you is this, which I've already taught for some students, is wavy curve method to identify sign of rational expressions. For quadratic also it is valid. It's also called as, some books say this is number line sign scheme to identify the intervals rational expressions are positive or negative. So let us say, I'll start with an example and then explain the concept. So let us say f of x is polynomial upon a polynomial. Okay, now you have x minus 2, x minus 3 the whole square, and x plus 5 the whole cube by x plus 1 to x minus 4 the whole power 4. No, I'll say whole power 5. All right, now this is a polynomial. It looks very complicated. All right, we want to find values of x for which f of x is positive. So the method here is, first of all, identify all factors with odd powers. Only these contribute to sign changes. What does that mean? Look, for example, x minus 3 whole square. This is whole square, so this will always remain positive, except when x equal to 3, this will become 0. Other than that, it will always be positive. So this will not contribute to sign change, because if you take values less than 3 or greater than 3, it will remain the same. So this will not contribute to sign change. So we identify only those factors that contribute to sign change. Okay. Next, equate all these factors to 0. Individually, and find the roots of the individual factors. Okay. So, and mark these on the, and mark these numbers on the number line. So yeah, this is the real number line. Look at this. X minus 3 whole square, you have to omit. All others have positive odd powers. 1, 3, 1, 5. Now equate this to 0. You get x equal to 2. So let's say 0 is here. So x equal to 2 is somewhere here. Then equate this to 0, x equal to minus 5. Equate this factor to 0. X plus 1 equal to 0, x equal to minus 1. All right. And equate x minus 4 equal to 0. So you'll get x equal to plus 4. Okay. All right. Now you should ensure. Now we want, so we want that this expression x minus 2 into x minus 3 the whole square and x plus 5 the whole cube by x minus 4 into x plus 1, sorry, x plus 1 x minus 4 whole power 5. This should be greater than 0. You can write equal to 0 also. Now, for this to be greater than 0, first ensure that this is step 3. Ensure that all factors have positive coefficient of x. If not, multiply the inequality by -1 to get positive coefficients of x. All right, here it is 1, 1, 1, 1. So all are positive, no problem. Suppose you had 2 minus x, then what you do? Multiply with minus sign throughout. So inequality will reverse. So now we have to see which one will be positive, which one will be negative. Now, once all coefficients of x are positive, then go to the extreme right. Go to the extreme right. So this interval 4 to infinity, mark positive. Then the next interval 2 to 4. All right, the next immediately next interval after the right will be negative. Then the interval between -2 to 1 will be positive, and then -1 to 2 will be positive, then -5 to -1 will be negative, less than 5 will be positive. So this will not be the exact graph cannot be exactly like this, but this will give you the region in which this given expression will be positive, the region in which it will be negative. Now, what is the logic? Why to the extreme right? To the extreme right, x is greater than 4. If x is greater than 4, x minus 4 is positive. Then x minus 2 will be positive. Then x plus 1 will be positive. X plus 5 will be positive. That means x minus 4 is a positive quantity because x is the largest number. If x is in this region, let's say you choose 6. So 6 minus 4 positive, 6 minus 2 positive, 6 minus of -1 positive, 6 minus of -5 positive. So that's why you get plus. Now in this region, x, if x lies in this region, x minus 4 will be negative. X minus 4 will be negative because x is lesser than 4. So this particular term is negative. X minus 4 is negative. But all other terms, x minus 2 will be positive because x is greater than 2. X minus of -1 will be positive. And x minus of -5 will be positive. So x plus 1, x plus 5, and x minus 2, they are positive. So in all the product, one negative value. So the product becomes negative. That's why it is negative. Now when you come into this region, -1 to 2, so x, if x is here somewhere, then x minus 2 is negative and x minus 4 is negative. So this is a negative term and this is also a negative term. Now both contribute negative sign. Negative divided by negative is positive. So that's why, and remaining are positive. That's why it is positive. Next interval you go, product of three negatives. X plus 1 is negative, x minus 2 is negative, and x minus 4 is negative. So three negatives, product of three negatives will be a negative. That's why in this region it is negative. And less than -5, 4 are negatives. 1, 2, 3, 4. 4 factors are negative. So it will be, product will be positive. So I did not calculate all this in detail. once I ensure that the coefficients of x throughout are positive, all right, I just went to the extreme right, and alternatively, I did not. I removed 0 in between so that I don't get confused, because I only want to write the the roots of these individual. When you individually equate these factors to 0, what are the roots you get? -5, -1, 2, 4. I arrange them in ascending order in the number line, and when to the extreme right, start marking plus, minus, plus, minus, plus. You can do it. 100% assured you will get uh, the region in which the expression is either positive or negative. So for given expression to be positive, f of x, no? So f of x to be positive, we have for x, f of x to be positive, x must belong to, observe this region, minus infinity to -5, union -1 to 2, union 4 to infinity. Okay. Now, if f of x is negative, then x belongs to this region, -5 to -1, union 2 to 4. This is, sorry, -1. Okay. So this is the way we do. This is the standard method to do for any polynomial. This is applicable to quadratic equation also. So have you taken down? Can I move forward? I'll take class for another 10 minutes. So after that, others you may have. Okay, someone asked an important question. If we equate the denominator factors to 0, the function becomes undefined at that point, correct? The function becomes undefined at that point. However, we are interested to find where the function is positive, negative. That's why this graph, this is not the right graph. At -1, x equal to -1 and x equal to 4, the function will not be defined. Actually, this will tend to minus infinity and this will tend to plus infinity. Okay, so you're right. However, this method is only to find out whether the expression is having positive sign or negative sign. Okay, good question. Now I'll give quadratic. I want you to do quadratic expressions also exactly like this. Okay, once you have done this, I'll say solve the inequality. Solve the inequality. X square minus 6x plus 8 less than 0. Very simple one. There's a quadratic. I started with a very complicated problem. Okay, the previous example. Now I am coming to very simple one. How to do this quadratic? X square minus 6x plus 8 less than 0 will imply x square minus 2x minus 4x plus 8 less than 0. You get x times x minus 2 minus 4 times x minus 2. So the factors are x minus 2 and x minus 4. All right, we need this to be less than 0. From quadratic expression, we know that x minus alpha into x minus beta less than 0 means x should lie between alpha and beta. Okay, now the same thing by this wavy curve expression. What are the roots? X equal to 2 and x equal to 4. Now coefficients of x are positive. Go to the extreme right, plus, alternate minus, plus. And because we know it's a quadratic, we can draw the graph like this. So in this region it is positive, in this region it is positive, in this region it is negative. So solve the inequality means for values of x. So x belongs to 2, 4 for this inequality to hold. Understood? How we used wavy curve method to do it? Got it? No one is responding.
Yes, sir.
Yes, sir. Yes, sir.
All right. Now I'll give you another one. Solve let me take a negative 3. Okay. I will do 21 10x minus x square. It will be minus or plus. I have to see. Okay. Minus it will not be 10 4. Okay. Now condition for this to be negative. How will you do? Straight away multiply with a negative sign and solve. That is one. Other way is minus 21. I can write as 7 into 3. So I will get minus 7x plus 3x minus x square less than 0. This will be
Sir, minus infinity to 3 and 7 to infinity.
okay. So now I'll get, if I take 7 common, 3 minus x plus x common, 3 minus x less than 0. So I'll get 7 plus x, 3 minus x into 7 plus x, that is x plus 7. Now I equate the factors to 0. Now if I have to use the number line sign scheme, I can equate the factors to 0. I'll get two values, x equal to minus 7 and x equal to plus 3. Now I should not immediately write plus minus here, because this is negative. Coefficient of x is negative. So what I'll convert, I will multiply throughout with minus sign. Then I'll get x minus 3. That minus sign gets multiplied with this factor. I get x minus 3 into x plus 7. Inequality will reverse. If this number is negative, I multiply with a minus sign, it becomes positive. Correct? So I need to solve this. So now, because coefficients of x are positive, go to the extreme right, write plus, minus, plus. All right? You get x belongs to minus infinity to minus 7, union 3 to infinity. Got it? All right. So these are the ways to the same number line sign scheme. We use it for quadratics this way. These inequalities you should be thorough with quadratic. I've given these because it will repeatedly come in calculus, which we'll do later, and domains of functions, algebraic functions. And so, all right. Any questions? Those of you who have questions on trigonometry, the quiz that we discussed. Okay, I have uploaded the solutions. But still, if you think that you didn't understand some part, I will explain. Yeah, Mithilesh, I got. I think you have been added. I got the message. I asked the technical person to add this thing. So by